Hello and welcome back. This will be the third and final part of the Polynomial section, Section 4 in the Prerequisites chapter. And just to review really quick, we've seen a couple of special products of, say binomial. If you're going to multiply conjugates, meaning a plus b and a minus b, we will just get a squared minus b squared. If you square a plus b, so a plus b times a plus b, we get this formula where we have an a squared and a b squared plus 2 times the product of a and b. The same way, if we have a negative sign, we end up changing the sign of one of these terms, so it'll be minus 2 times ab rather than plus 2 times ab. And more general formulas exist. I won't go through where they actually come from, but say this first one, if you cube a plus b, so take a plus b to the third power, we'll get this formula. You can sit down and just multiply all this out. It's again very straightforward to just multiply this to distribute this and come up with this formula. But I won't go through the details in this video. Here I will just apply this formula. So I have a 2x plus a 3. So we see the first term is just going to be the first term cubed. So we'll take 2x to the third power plus 3 times the first term squared times b, which is 3, plus 3 times a, which is 2x, times b squared, plus b, which is 3 cubed. Again, all I've done is I've plugged in 2x and 3 in for a and b in this formula. And then now we get to go through and multiply all this out. So we'll do this fairly quickly. 2x cubed, the 2 cubed is 8, x cubed is x cubed. Here I'll have a 3 times 2x squared times 3. So 3 times 2 times 2 times 3, 9, 1836 times x squared. Plus 3 times 3 times 3 is 27, times 2 is 54, times x, and 3 cubed is 27. So again, I've just multiplied all these out fairly quickly here. And then lastly, if instead of taking the cube of the sum of two things, we can take the cube of the difference of two things, and it's a very similar formula. We just have a couple of negative signs pop out in a few places. So again, let's use this formula. So I've got x minus 5 cubed, so x is going to be a, 5 is going to be b, so I've got x cubed minus 3 times x squared times 5 plus 3 times x times 5 squared minus 5 cubed. And going through this, we can simplify this. X cubed is just x cubed minus 3 times x squared times 5, so that's minus 15x squared, plus 3 times 5 squared, 5 squared is 25, times 3 is 75, times x, minus 5 cubed, which is 125. So again, this is just plugging this into this formula. This formula is not hard to find if you go through and you multiply this carefully. It just takes a little bit longer. Now, one thing that we haven't addressed is the fact that you can have more than one variable, and a polynomial can have more than one variable in it. So for instance, here's a polynomial. Why is this a polynomial? When you look at all the variables, say an x and a y, and you look at where they show up throughout this, you'll notice that all of their exponents are whole numbers. It's x to the third power, so we've got a 3. Y by itself is y to the first power, it's 1, 2, 2, x to the first power, 2, y to the first power. All of the powers are whole numbers, so these are polynomials. So just like before, we can talk about the degree of a polynomial, or degree of just a term. So here the degree of a x to the n, y to the m is just going to be the sum of their powers. So we can think of this as just the collective sum of all of the variables present in there. If there are more than two variables, x, y, and z maybe, and so on and so forth, we would just add all of the exponents, all of the powers, and that's the degree. So here, let's look at a few of these degrees. We have x to the third and a y, so the sum of those, so this has degree 4. X squared and y squared, 2 plus 2 is also 4. So you can have the same degree while having different combinations of these powers. Here, this will be a degree 3 term. This is a degree 1 term. I've just got y to the first power. And then finally, constant terms are called degree 0. We can think of this as being y times x to the 0 power. So we have all these degrees. And when we simplify things, we want to simplify like terms. And like terms means that they have to have matching variables with matching powers. So just a quick example here. Here's another polynomial with two variables in it, x and y. And what you'll notice is that the first term and the second term are going to be like terms because they both have an x squared and a y squared. So we can add these two guys. So 3 times x squared y squared plus 6 times x squared y squared. This will be equal to 9 x squared y squared. Now we still have this last term hanging off, and this is not a like term because even though they both have x's and y's, this x is raised to the second power, that x is raised to the third power. And we don't even need to check the y, but again, the y is raised to a different power. Y is squared and this y is not squared. So these are not like terms and we cannot combine them. Even though their degrees are the same. The degree of this term, the first term, is 4. The degree of the second term is 4. So it's not good enough to have the same degree. They have to have exactly the same variables with exactly the same powers. And just like with polynomials in one variable, we can add and subtract them. I'll go through an example of subtraction, and then I'll go through a couple of examples of multiplying these sorts of polynomials as well. So let's subtract these polynomials. So again, we have the first polynomial, and what I will do, just to keep things, just to make sure that we're all on the same page, I'm going to make everything into addition here first. So I'll say that this is going to be plus negative 7x squared times y plus y squared plus a negative 6. And now I'm going to subtract the last terms here. So again, I have to distribute this negative sign across every term in here. So we're going to be subtracting x cubed, which is the same thing as adding a negative x cubed. I'm going to add, again, a negative 2x squared times y with the negative sign, and I'm also going to have a negative 8. So I now have a bunch of things that I'm adding together. It doesn't matter the order in which I do so I can rearrange this. And what I'll do is I'll rearrange this so that like terms are next to one another. So everything with an x to the fourth I'll put out front, and it turns out that this is the only term with an x to the fourth. Maybe next I'll look at x squared times y, and I have one term here, but I also have a second term near the back, so a negative 2x squared y. These will be like terms that I'll combine in a second. So let's mark these off. I'll underline the ones that I've used. Next, I've got, let's say, an x cubed here. We've used that one. There are no more x cubes. I have a y squared. And then lastly, I have the two constant terms. So plus a negative 6 plus a negative 8. So this is getting kind of busy, as in there's a lot going on the page, but you'll notice that I've arranged these again in descending order in terms of the degree. I have the highest degree out front, followed by the next highest degrees, which are going to be 3, and then degree of 2. There are no degree 1 terms, and a couple of degree 0 terms. Now I can combine some like terms. There are no x to the 4th terms, so that just stays around. I have a couple of x squared times y terms, so I have -7 of those, -2 of those. That turns into -9 in total. I have my x cubed term there, plus a y squared, and -6 and -8 adds up to -14. So nothing has changed. We just have to be a little bit careful with combining our like terms. And then the last couple of things we'll do is we'll just multiply a couple of polynomials. These will in fact be binomials with only 2 terms in them. So here I've got x squared minus y times 3x squared plus 4y. Multiplying binomials, let's FOIL. So we'll take the first terms, so x squared times 3x squared. The outer terms, x squared times 4y. The inner terms, I have a negative y times a positive 3x squared, so negative y 3x squared. And then the last terms, so negative y times 4y. And again, we'll just have to simplify this a little bit. So this first term will be 3 times x to the 4th power. Next, x squared times 4y, so this would be 4x squared y. You'll notice that I'm always putting the number out front, and then the x, and then the y. It doesn't have to be that way. It's just easier for me to keep track of. Next, I've got minus 3x squared times y, and then minus 4y squared. And the terms in the middle are like terms because they're both x squared times y, so I can combine these guys. 4x squared y minus 3x squared y is just 1x squared y minus 4y squared. And then the very last thing, we are squaring a binomial, and we have a formula for this. So remember that this will be, so if it's a plus b quantity squared, it'll be a squared, so we take the first term and we square it, plus 2 times the first term times the second term, plus the last term squared. So again, this is just using the formula, a squared plus 2ab plus b squared. And again, this is fairly simple. X times y squared will just be x squared y squared. We have 2 times x times y times 4, so that's a total of 8 times x times y. And 4 squared is 16. And this is all I'll say about polynomials in this chapter, although they will continually turn up throughout the rest of the semester. So this is a good chapter to practice.